Okay, good morning, class. Okay, with regards to the learners that came over today, you have an assignment due on Monday. Please do the assignment. Who is the class admin? Sorry? Jaden. Who's Jaden? Where is she now? Bottom, okay. So tell me to add the people who join the class today. Okay. Oh, yeah. Why you, Jaden? You must add the new people, okay. Also, just on the group, send what is needed for Monday. Okay, it's a handy assignment. You do it on folio paper. And on Monday, at the beginning of the lesson, we'll collect it. And we'll keep it, and then we'll discuss a couple of lessons later what is the shortfalls of that assignment. Okay. You know you're writing on Tuesday. You're writing on geometry. Geometry is 35 marks. And trigonometry, which is the introduction, which is basically grade 10 trigonometry. You're going to write that for 15 marks. Okay. Also to the group, I've sent a link to the videos for those of you who want to revise the grade 10 geometry over the weekend, trigonometry over the weekend. You may do so. Also for those of you who want to go over the geometry, it's on the YouTube channel. Okay. That said, let's do this. So today's topic is trigonometric ratios. Now some would teach chapter 6 first, which deals with trig graphs, but I like teaching chapter 7 to an extent first, which is till 7.10. Then I go back to 6. Then I do the graphs and all of those things, including the solutions and general solution, and then come back to wrap up question 7. That's topic 7. So this is some revision on basic trigonometry. We are told in grade 10, the three trigonometric ratios, sine, cos, and tan, where theta is an angle of any right angle triangle. So in grade 10, all the triangles, or trigonometry basically, was done in right angle triangles. Okay? This year we're going to look at non-right angle triangles, where we're going to apply trigonometry in as well. Okay. So, when we started off trigonometry, which page is this on? Sorry? Page 225. 220. Okay. So, what we done in grade 10 were many things, not so. We spoke about sine, cos, and tan. Okay, firstly, it also was done in a right angle triangle. Not so. Then we spoke about beta, theta, alpha, omega, and all of those things. Where theta, alpha, beta, omega, they were all denoted to unknown angles. Okay? And we said that theta, beta, alpha, and all of those angles is the same as variables x, y, z, a, b, c, and so on. The same thing. Okay? Then we said that this angle here, if that is your angle theta, this is your hypotenuse, h, this is your opposite, which is O, and this is your adjacent side, which is in turn A. Not so. However, if you're referring to this angle there, or it can be represented as theta minus 90 minus theta, any one of the two. If the angle is this referred to there, then that is your opposite. Not so. And that is your adjacent. Your hypotenuse will remain your hypotenuse because the hypotenuse is along the side. Not so? Alright. So that's that. Sine cos tan, that means nothing without an angle. Okay? So, sine, we need an angle theta here. We're referring to the diagram alongside. So sine of theta, sine is opposite over hypotenuse. Cos is adjacent of hypotenuse, and tan is opposite of adjacent. Many of you remember at SOHCAHTOA, no problem. I remember it as Oliver has a hat of apples. Okay? In that order, we always write sine cos tan, and that's the order on your calculator as well. Okay? Then we were told about the quadrants. Okay? We spoke about quadrants. So this here will, if we start that to be 0 degrees, every quadrant is 90 degrees. Not so. So from this point to this point here, it's 90 degrees. From there to here, 180 degrees. From there to there, 270. And to there, 360 degrees. Okay? This was our first quadrant, our second quadrant, the third quad, and the fourth quad. That quadrants will remain that quadrants even if you go sleep tonight and get up tomorrow morning. Okay? It doesn't change. Okay? Also with regards to the quadrants, we have all stations to Leeuwen. Okay? All Cape Town. All stations to Cape Town. Okay? And you guys know what that stands for? Okay? What does that stand for? All is positive, yes? Sine is positive. Tan is positive. Cos is positive. Okay, which means to say, if it's tan or cos in the second quadrant is going to be negative. If sine or cos is in the third quadrant, negative. Sine and tan in the fourth quadrant, negative. Any of those in the first quadrant, positive. Okay, that is basically what that stands for. Alright. Then, you guys were also exposed to, what was the other thing you guys were exposed to? Yes, good start. What else were you exposed to? No, that's not all. Did you guys speak about special angles? Yes. So the special triangles was of 3. Not so? There's a 45-degree angle triangle, which is your tan of 45, which is 1, so it's 1, 1, root 2. The other one? Sorry? 30 and 60, or 60 and 30, yes? So sine of 30 is half, so it's 1, 2, root 3. The other one? 0. This is not a triangle. So don't try and prove it's not a triangle to me. I know it's not a triangle. But it works for what we are looking at. Okay. That's 1, 1. That is no length here, of course, it's here. Okay. When you do the exam, and the question says, without the use of the calculator, I expect you to draw this next to the sum. Okay? Is it for marks? No. But that eliminates the fact that the examiner will think you are using a calculator. Okay? To actually do the sum. So if you put this next to the sum, we can clearly see you know what you're talking about. Okay? So make it a habit of writing this down. Also, there will come an exam next year called the NBT, the National Benchmark Test. It's a maths exam we write for universities like UCT and Stellenbosch. Okay? And I think Wits also. You write this NBT, this National Benchmark exam. It's a maths exam of 3 hours in which you're not going to be allowed to use it. All trigonometry is based on these techniques. Okay? So in the meantime, learn the techniques. Expose yourself. Okay? Then you spoke about cosec and cosec, not so. Right, but that is for grade 10. Okay? Here everything can be done with sine, cos and tan. Okay? So let's look at some examples. It was given in this textbook, a brief overview of the general trigonometry covered in grade 10. We're going to look at those examples, okay? Which page is this on? Huh? 223. Okay, so here we are told in which quadrant does x lie if tan is greater than 0 and cos is less than 0. Write this down. We'll discuss this now, okay? Okay. Now we can tell me which quadrant does that lie if tan is greater than 0 and cos is less than 0. Yes? Third, let's check. If it says that tan is greater than 0, what does that mean? Tan is positive. So it's in the quadrants. Remember that's quadrant 1, 2, 3 and 4. This is all stations to clear. Not so. Tan is greater than 0, that means to say tan is positive. In which quadrants is tan positive? 1 and 3. It will always be positive in 2 and negative in 2. In which quadrant is cos negative? Quadrant 2 and 3. Not so. So therefore, it's in the third quadrant. Okay, do you guys understand? Any confusion? Any confusion? No. Right. Go to the next one. Example 2 on page 2 to 3. Write it down, then answer the question for me. So in example 2, we are told if 13 cos alpha plus 5 is equal to 0 and sine is greater than 0, determine without using a calculator the value of. So if this sum is given, the best would be is to draw a sketch for this for the sum. Okay, draw a diagram. So what we do is we first get cos of alpha on its own. Okay, so how do I get cos of alpha on its own? Take the 5 over, yes, and divide by 30. So it will be cos of alpha is equal to negative 5 over 30. Right, what now? Okay, now we are told that sine is greater than 0. So the question that comes to mind at this point is, what this tells us that cos of alpha is equal to negative 5 over 30. That means to say that cos is negative, is less than 0. Okay? So in which quadrant would that appear in? So it's all stations to Claremont. So in which quadrant is cos negative? 2 and 3. But here we are told that sine of alpha is greater than 0. What does that mean? Sine is positive. In which quadrant is sine positive? First and second. So in which quadrant am I going to draw this in? Second quadrant. And there's your alpha angle. Remember, the angle will always be drawn from this arm here. Even if it's very close here, it will be drawn like that. Okay? It will always be drawn from that arm. Now you fill in the information that you can at this point. Okay, so what does cos stand for? Adjacent over hypotenuse. So if this is the reference, that is your adjacent here. So the adjacent is negative 5. The hypotenuse is 30. Normally I don't write the negative in immediately, but as you can see, this is on the negative part of the x-axis, not so. So that's where the negative is. The hypotenuse will never be negative. Okay, so how do I get the side here? How do I get that unknown side there? I use Pythagoras. And why do I want to know that? I want to know that so that I can calculate tan and I can do the calculation on sine as well. Okay. So how do we get that, people? Let's call that opposite for now. So opposite squared is equal to hypotenuse squared minus negative 5 squared, which gives you 144. Is that correct? 144. The square root thereof is going to give you okay. You see, you didn't learn Pythagoras for nothing in grade 8. Now what's the question? The question is to calculate 13 sine alpha minus 5 tan alpha. 13 sine alpha minus 5 tan alpha. Okay? So with the diagram now, do the substitution. So what does sine stand for? Opposite, which is 12, over hypotenuse, which is 30, minus 5 times. Tan is adjacent, which is negative 5, opposite, which is 12 over negative 5. Not so? That cancels, gives you a 12 plus 12. Is that correct? The answer is 24. Okay, are you all okay with that? Any confusion? No, not yet. Okay. In example 3 on page 224. Without the aid of a calculator, determine the value of, the first one is sine squared 60 plus sine squared 30. So what do we need there? What do I need? Without the calculator, girlfriend. Are you checking? Okay. You're going to use your special angles. And which special triangle is needed here? The one dealing with 30 and 60, or 60 and 30. So do that for me quickly. So what will this be? Sine of 60. They do 60. Sine is opposite over hypotenuse. So it's root 3 over 2. Because there's a square there, the square belongs. But remember that sine squared 60 is sine 60 whole square. That's basically what that means. So you can't square a function. You can't square sine itself. Okay? But the reason why they write it like that is because it's a shorthand notation of what's it. Plus sine of 30. Sine is opposite over hypotenuse, which is being squared. So it's going to be root 3 over 4 over 4, or 3 over 4, sorry, plus 1 over 4, which is 4 over 4, which is 1. Any confusion there? No? The next one. Again, without the use of a calculator, determine the value of. So what do we need here? Many things. Not so? We need, which triangles do we need here? All three. Not so? There's the 1, 2, root 3, 60 is here. There's 45, 1, 1, root 2. 1, 1, 0. Okay, so sine of 30. Sine is opposite over hypotenuse, so it's 1 over 2 times tan of 45, 1 over 1. Sine of 90, opposite of hypotenuse, is 1 over 1. Cos of 60, adjacent of hypotenuse, so it's 1 over 2. So that is 1, 1. 1 over 2 divided by 1 over 2 is 1. So the answer is alright, you all have that. It's fairly simple, no? Then I told you to do exercise 7.1 yesterday, not so. So, did you have any problems with number 1? Number 2? Sorry? No? Number 3? No? Number 4? Yes, so let's look at number 4. It's on page 225. Okay, so here we are told if 12 tan c plus 5 is equal to 0. 12 tan c plus 5 is equal to 0. So what do we do first with that? We make c the subject of the formula. No, so? Right. So we take the 5 over and then divide by 12. So tan c is equal to negative 5 over. So what does that tell us? That tells us that tan is negative. In which quadrant is tan negative? 2 and 4. Okay. Then we are told that c is an element of 90 to 270. So that means to say that that angle C lies anywhere between 90 is on top, 270 is at the bottom. So 90 to 270 is 2 and 3. Can you see that? You understand? You look so confused. It says C is an element, if they tell you C is an element of 0 to 180. What are they referring to there? That's 0, 90, 180, 270, 360. Which quadrant is that in? First and second. If they say that C is an element of 90 to 360, which quadrants are they referring to there? There's 90, so it's 90. Third, fourth. Not so. If they tell you that theta or C is an element of 270 to 360, which quadrants are they referring to there? The fourth quadrant. You understand? So that means to say I must draw this diagram in the second quadrant. Here's my angle C. Okay. What does tan stand for? Opposite over adjacent. So fill in the information now. So we go opposite is 5, adjacent is 12. Now coming to the sign here. This is on your positive part of your y-axis, not so. Therefore, y is positive. Can you see that, people? So the 5 is positive. This is on your negative part of your x-axis, not so. Therefore, your 12 has to be negative. Hence that negative there. Remember, if that negative is written, that negative 5 over 12 is the same as 5 over negative 12, which is the same as 5 over negative 5 over 12. Not so? So what do I do now to calculate the hypotenuse? How do I calculate the hypotenuse? Applying Pythagoras. Not so? So apply Pythagoras? Yes?
So anything that's on, okay, see what the 5 is, anything on that line will be negative.
Sorry? But the 5?
Yeah.
Always be positive. Yeah. Why? Because it's on the positive. This is on the 5 is on the positive part of your y-axis. Can you see that? That is much your y here. And that's your positive numbers here. Here's your negative numbers. Not so? Right. So let's go with that calculation quickly. So it's going to be the hypotenuse squared is equal to negative 5 squared plus 12 squared. So that's going to give you 169.
Yes.
The root thereof is 30. But what was the question? The question is, you must calculate the value of 12 tan C. So you got 12 tan C minus 13 cos C. So, it will be 12. What does tan of C stand for? What does tan stand for? Opposite over adjacent. So it's going to be 5 over negative 12. I could have taken it from here as well, no? Doesn't matter. Cos. What does cos stand for? Adjacent over hypotenuse. So it's negative 12 over 30. Okay. So what happens now? Cancel. So it's negative 5. Negative times negative is positive. And negative 12, 5 plus 12 is 7. Okay. Any confusion here? No. So that was number 4. Any issues with number 5? 5? No? 6? Anybody had a problem with 6? No. 7? No. Okay. Yes?
How much is number 4 and
If you're looking at number 4, the question is, how much is this question worth? I would say 4 marks, 3 or 4 marks. Okay. Yes? If the question says with the aid of a sketch, then you must draw a diagram and then you'll get the mark. But that mark is already incorporated in the 4 marks. Otherwise, how else are you going to do this? So I don't know how else you're going to do it without the diagram. The reason also why they tell you, I can get 7 out. Let me show you quickly something. If I've calculated, this is with the calculator. Okay. If you go and you work out tan C is equal to negative 5 over 12. No? Then angle C is equal to arctan of 5 over 12. This is now when I want to work out the angle. No? So I'm dropping the negative angle there. So it's going to be arctan of 5/12. Is that the D? Yes? Okay. So that reference angle is 22,62. So this angle here, this whole angle, that angle that I've calculated is actually that angle that's lying there. So angles on the straight line adds up to 180. No? So I say 180 minus that. So angle C is actually, but we're going to get to this calculation still. But angle C is equal to 157,38. Okay. So what they do is they then substitute. So you say 12, 10, 157,38 minus 13 cos 157,38. So you put that in the calculator. So it's 12, 10. Remember the answer is the last answer calculated in the calculator. Minus 13 cos that same answer. See, and you get 7 again. By saying you, without using your calculator, I cannot do that. You understand? And that is this another way of calculating and assuring that the answer is good. Yes?
So what are you going to
We get into that. You see, the reason why I leave out the negative is because you remember we said we're going to change? No? You're not going to be negative anymore. Remember? So, since we're having now a positive outlook on life, we're going to use positive value. Okay. People, now we're looking at trigonometric identities. Trigonometric identities. Yes? Any question? No. Okay, I want you guys to write this down. Your heading is trigonometric identities. We're on page 225. A trigonometric identity is a mathematical statement that is true for all values of the angle except for those for which the statement is not defined. Okay, you write that down. The two fundamental identities are as follows. What are the two fundamental identities? Who can remember? Sine squared x plus cos squared x is equal to 1. Don't you guys remember this from last year? No. Okay, no problem. But I'm sure you remember this. The tan of x is equal to sine of x over? You don't know that either? No. Okay, nice. Let's show you where it's coming from. Who's the daddy, no? You all want to know who's the daddy. So basically what happens is, if this is your angle theta, and this is your 90, then this is your opposite, and your nice. Can you set up a formula for an equation? Can you set up an equation using O, A, and H? Any formula? Or any equation? Yes, you can. Well, which one? H squared, yes, is equal to? Nice! A squared plus O squared, or O squared plus. And where is that coming from? From Pythagoras. No? Not so. So let's see what's going to happen if I divide that whole line, or that whole equation, I divide it by h squared. Let's divide this whole equation by h squared. You'll see now why. Don't worry. Don't ask me why. You'll see now why. Divide the equation. Let's see what we get. We're going to get, this will be over h squared, that will be over h squared, that will be over h. Not so? So what do we get? H squared over h squared is 1 equals. But a squared over h squared is the same as a over h all squared. Not so?
Yes.
Likewise, O squared over h squared is the same as O over h all squared. Not so? But A over h is what? Because sine, cos, tan is Oliver has a hat of apples. You see, A over h is what? Cos, yes. Does it become cos squared theta plus O over h all squared, O over h sine squared theta. Not so? So that means to say that sine squared theta plus cos squared theta will always be equal to 1. So what's sine squared 20 of cos squared 20? Sine squared 20 plus cos squared 20? 1. What's sine squared 100 plus cos squared 100? 1. Can you see that, people? Sine squared 2a plus cos squared 2a? 1. Sine squared 50 plus cos squared 40? Not 1. Why? Because the angles are not the same. The angles must be the same. Do you understand, people? So put that in a coffin, in a box. Yeah, in a box. No? What's a coffin? It's a box here. So another formula can be derived from there by making cos the subject of the formula. Not so. What can we say? Cos squared theta equals 1 minus 1 minus, yes, sine squared theta. The other hand, sine squared theta is equal to 1 minus cos squared. That's a derivation from that formula now. That is derived from the original formula. Okay? You guys understand? So sine squared theta plus cos squared theta is 1. Okay. And let's take this one. Let's try something different. Oops. Let's see what sine of theta divided by cos of theta would give us. Sine of theta divided by cos of theta. What does sine stand for? Can it be opposite over hypotenuse? That must be divided by cos. Cos is what? Adjacent of hypotenuse. Not so? So that you're going to change to multiplication, you tumble and times. So do your thing and simplify. So that can be written as O over H times H over A. The H's can cancel, which is equal to? But where else do you see O over A? Can you see that, people? So what does that mean? That means to say that sine theta over cos theta is equal to tan theta. Put that also in the box. Tan theta is going to be sine theta over cos theta. And this is what we call the fundamental identity. So what is sine 20 over cos 20? Tan 20. What is sine of 2 alpha over cos of 2 alpha? Tan alpha. What is sine of 30 over cos of 20? Not the tan over 20. Not so. Why? Because the angles must be the same. Okay. Verstaan julle? Ja, okay. Mzikelo 1. Hey. You think I can't speak, Oza? Mzikelo 1. Well, the bell's going to ring soon, so I'm going to go straight into it. It's 2 to 6. Your homework is going to be exercise 7.2, number 1. Exercise 7.2, number 1. There are quite a few sums there on page 2 to 7. I want you guys to do that for homework, okay? Then we will do the second lot of examples tomorrow, okay? Sure. 2 to 6. Okay, here we go. So bear in mind that sine square theta plus cos square theta is 1. Then we know that sine theta over cos theta is tan theta. Very important, no? So here we are told, use the fundamental identities, which are those two we spoke about now, to simplify the following expression. So, let's look at number 8. You got tan theta times cos theta. Sine tan theta times cos theta. Now tan theta can be written as what? Sine theta over cos. Nice, yes. So easy. I can't believe it. Times cos theta over 1. So simplify for me. So that the causes cancel. Leaves you with sine. Right, you guys understand?
Yes.
Let's try B. You try B for me. Okay. What can happen here? 1 minus sine square theta is the same as cos square theta. So it will be cos square theta over cos theta. So what happens here? Cos theta cancel with one of those two on top. Not so. Leaves you with cos theta over 1, which is cos theta. You will understand. Anybody that's confused? What are you confused about, Michael? Remember that you must listen. There is a tan. Tan can be rewritten as sine over cos. There is a 1 minus sine square theta. Remember earlier on we had if sine square theta plus cos square theta is equal to 1. So 1 minus sine square theta is going to be yeah, you got it. Is it because the bell rang or is you really understand?
Your attention please, all drama learners, can you please meet Mr. Swartz in the music block now at break? All drama learners, can you please meet Mr. Swartz in the music block now at break? Lalita Nonchakaza and Rachel Chirwa, can you please report to the office for a collection?
Okay. So what we're going to do here is we're going to find an LCM. Not so? What's the LCM here? Sin x. So that you must multiply it by sin x. You multiply the numerator also by sin x. So sin x times sin x, sin squared x plus. Sin x times what is sin x? Times 1. Which gives me cos squared x. So what is sin squared x plus cos squared x? What's sin squared x plus cos squared x? 1. So it's 1 over. Right, you guys understand? Any confusion? No? The last one? What's your LCM here? What's the LCM here? Cos x sin x. So sin x cos x. Not so? So this must be multiplied by sin x. This must be multiplied by cos x. So what's sin x times sin x? Sin squared x plus. Cos x times cos x? Cos x. So what's sin squared x plus cos squared x equal to? 1. So that's 1 over cos x sin x. And there we go. Okay. With that information you should be able to do exercise 7.2 number 1. Do enjoy the rest of your day. Good morning, class. Yeah. Let's put this here. Bye. Bye.